Hi, hello. So, I am Anusha. Today, I'm here walking you through my Capstone project called BudgetSense AI Analyzer and Advisor. Before we get into the technical aspects of the projects, let me start with something we'll all experienced. So, most of us think that we know where our money goes each month, but the moment we open our bank statements, things get messy very quickly. Every bank uses a different format. CSV exports come with strange column names, sometimes values are missing, dates are inconsistent, and even after cleaning all uh, the columns and everything manually, most tools only give you simple charts or basic statements like you spent $380 on dining. That's not helpful. People want clarity and guidance, not just totals. So all about my project or my idea here is like people will be expecting like where exactly did I overspend, what changed compared to last month, or how can I adjust my budget realistically. It's like understanding about the comparisons before the last month versus the current month, and some budget advices considering and analyzing the previous budget spendings, overdues, and all of it. So with my application, what it does is the goal of budgets in AI is it takes the messy, confusing financial data and turn it into clean, insightful, personalized budget guidance without the using the any other applications or user doing or any cleanup. So to address this problem, what I have used to solve this is I've been using a system end to end. I used like six components majorly to address the workflow and everything. So majorly I've been working with the Pydantic schemas, custom Python tools, a long-term ledger to store the session and the budget files, a Gemini multi-agent system, a sequential Python orchestrator, and a Gradio UI to understand the execution in a simpler visual UI. Coming to each of it, I've been using Pythantic schemas to enforce structure and prevent dirty data from ever reaching the AI. And custom tools like for CSV ingestion, validation, normalization, and memory management. Coming to the ledger, a JSON-based historical store that grows with every upload. And usage of Gemini multi-agent system is like one agent handles the ingestion, other handles the financial planning. So in this way, I have segregated and did not overload a single agent duties. And I've been following here a sequential Python orchestrator to ensure predictable, reliable, and multi-step execution. Whereas a Gradio UI, so the user can simply upload a CSV and receive a financial report. These components work together like a real financial analysis pipeline. Now that we have understood what I have used, I'll just walk into the uh, steps like why I have been working with a specific things. Coming to the agents, like why did I choose the agents or why I have been working with the agencies, like let's talk more about why I specifically needed a multi-agent architecture. Here is the thing. So, if you try to give one large model multiple responsibilities, clean CSVs, normalize data, remember past transaction, compare months, detect spikes, and then produce advice, the output becomes inconsistent because it's very tough to handle all and everything. The model forgets ingestion details when focusing on planning, and it forgets planning logic when focusing on cleanup. So for this, I separated the responsibilities. I have majorly using two agents, ingestion agent and a planner agent, where each of it has its own responsibilities. Ingestion agent, what it does is it reads the messy CSVs, fixes the unknown column headers, validates rows using Pydantic, produces a clean transaction list. Planner agent, it loads the historical spendings, compares month-over-month changes, detects spikes or reductions, gives actionable budget recommendations, and to make them work in sequence, I use a Python orchestrator that guarantees order and correctness. This creates a reliable, explainable, and evaluator-friendly pipeline, exactly what the Capstone expects. Uh, yeah, I have also outlined the Capstone standards to uh, to address the Capstone evaluation. So I've been working on keenly on the standards required. All right. Now that we have understood the problem, the solution approach, and why agents are involved, let's walk through the entire workflow cell by cell. And where I'll be scrolling through my notebook and I'll be explaining like my project workflow cell by cell. So here is my workflow where I've been designed for the execution of BudgetSense AI. Coming to the cell one, it is all the installation of the Python libraries, and it's the default one whenever I create a notebook. And this is all about my introduction and the core values, what have been addressed, and the implementation, technical architectural details, what we have been talking through. Like this solves the problem statement, what does it eliminates, and what is it using, and what can be the target analysis or the budget recommendations it shows. This is all about the agent persona, what is it using and all. Coming to the technical and architectural details, the features I've implemented here are like the multi-agent system and the sequential processing, and custom tools have been using to process the agent functionalities. I've been using the long-term memory management to save the analysis, and whenever a new updated month data is fed to the system, it analyzes the budget expenses based on the previous comparisons. And coming to the context engineering, I've been using the planner system instructions to ensure that the output is in high quality and professional. And I've been using the GL data flow where I've been managing the Gradio UI for both ingestion agent and the planning agent whenever in a subsequential way the user uploads a CSV. So coming to the cell one, let's start with cell one here. So coming to the setup and schemas, this cell lays the foundation for the entire project. So here coming to the libraries, I've been working with the pandas, Pydantic, Gradio, and I have imported some Python essentials like JSON, OS, and the date time. And whereas to define the input, I've been using the input default personal finance sample data set, which is already integrated and provided from the Kaggle notebooks. I've been trying to load that data set into the Kaggle file path variable, and I've been using this. And I have also defined a budget data JSON. This ensures consistent file access everywhere. So defining the Pydantic schema, here I define the transaction model with the date, vendor, amount, category, and source is income, to define the if it is income or an expense. And I've used this another transaction list, whereas this wraps a batch of transactions so tools can validate many rows at once. That completes the foundation of the cell one, and now the system has a strict clean structure of everything, every transaction moving forward. And in the cell 2, I have defined the custom tools, and let me go through that. Yeah, I have defined all the custom tools, well detailedly explained here. Majorly, I've been working with the save to memory and extract transactions from CSE. So each of it has its own features to implement, own data, or the own set of instructions to follow and provide the output. Uh, Coming to the tool one, this is responsible for the long-term history storage. Here is exactly what happens in the code. So let's go through and understand it. It receives a JSON string of transactions from the ingestion agent where it structured and everything it does. It validates the JSON using the pedantic schema. This guarantees type safety. It checks if the memory ledger already exists. If yes, it loads it. If no, it starts with an empty list and it appends the new transactions. So then it converts all the Pydantic objects into plain dictionaries. Whereas it also overrides the budget data.json file with the updated list. And it returns a message summarizing how many new records were added. So this tool is basically required and is essentially builds a financial history over time. So this is all about the summary of my save to memory tool function, which is returned for a specific use case. Coming to my another tool, extract transactions from CSV. What this handles is the hardest part is like CSV inconsistency. Let me explain it what the code is doing. First, what I'm doing is to understand the processing and to not overwhelm the model. I am just processing the 50 records from the input data set just to compare with my external CSV what I've been providing. As an initial data, I just used to process the 50 records at first, keeps the model load manageable for Kaggle. And then defining a flexible mapping dictionary. For example, the description, merchant, vendor name, everything goes under the vendor. Debit, credit amount, total amount is categorized under amount so that it is flexible for mapping the headers. It scans the incoming CSV headers, renames the columns based on mapping. If the source column is missing, it will fill it up with an unknown account, and in the final report, it gives us an advice to not to provide an inconsistent data for the next time, or if you wanted to process that again. Compute is come like negative amount when the negative amount income and the positive amount is as expense. So for the compute of for the computation, it is using the is income column. And for normalization, all amounts to positive, we are using the df amount dot abs. Looping through each row, convert it into a transaction object, building the transaction list, converting the entire batch into JSON, and then returning it back to the ingestion agent. So this is all about the extract transactions from CSV method. This tool essentially turns unpredictable real-world bank data into clean, structured, validated transactions. This is all about cell 2. Coming to the cell 3, so these cell 3 defines the custom schemas and the agent definitions, where it handles the fixed date, load history, tool schemas. This cell fixes two important issues and registers tools with ADK. So here is the full code flow, how cell 3 looks like. So these are all the tools which have been passing through the planning and the ingestion agents. Let me walk you through the cell. So what it does here is set a fixed reference date because the Kaggle dataset is from early 2018. So last 90 days must anchor to that lifetime timeline, and checks if memory file exists. If not, return empty list. It also loads the stored transactions. If time period equals to all, it returns everything. Else, if time period equals to last 90 days, if the comparison or the user wants to compare it within last 90 days, it returns the exact 90 days, exact the number of days, compute cutoff date, reference minus 90 days, and it converts every transaction date into a date time, keeping it only those dates within the range. It returns the filtered transaction, so this ensures the planner agent always receives meaningful data. So this is all about the refined load history, redefining load history method. And next, coming to the tool schemas, here we define how the agent sees each tool, like the parameters, descriptions, output schemas, function names. Without this, Gemini cannot use our tools. So these are all like for defining the agents to see how each tool is required. And at the last, we are grouping all these tools and we are assigning it to the ingestion tools and the planner tools to allocate them what tools they can be used to process their agent workflow. So this is all about cell 3. Coming to the cell 4, agents and orchestrators, the whole multi-agent logic is handled in this cell 4. So this cell is the brain of the entire system. It consists Gemini initialization, two agent personalities, a multi-step orchestrator, tool called execution logic. Let's walk slowly through this. So coming to the part one of it, what it does, it loads an API key from Kaggle secrets. Here I've already added the API key in the secrets, and it loads the API key from the Kaggle secrets, try to create the Gen AI client, print status message for debugging. It's simple, but really essential. And coming to the system instructions, what it does is these instructions determine how agents behave. Coming to the ingestion agent and the planner agent, let's go one by one. Ingestion agent, what it does, it must call only extract transactions from CSV, no additional tools, no natural language responses, no planning, no extraction. It just this keeps ingestion deterministic and structured so that the output from ingestion agent is passed to the planner agent and then the subsequential steps are carried out there. Coming to the planner agent, this is another one more complex but intentional. And what it does is it must start by calling the load history, last 90 days data, compare the last 2 months, month one versus month two, identify category spikes. If it is like greater than $50, highlight categories that improved, analyze spending per card or account, produce a structural financial report with summary, category comparison, actionable budget suggestions, and definitely output only the markdown report. So this creates evaluator friendly clarity and stable output. So this is all about the planner agent. And in the run multi-agent flow here, what it all does is it loops the sequential output flow. So here, when the user uploads a file to which month or from which date he wanted the expense to be analyzed and advised, whenever the user uploads a file, it sends a prompt to the ingestion agent. Agent proposes tool called extract transactions from CSV, and then Python executes the extract tool, not the model, prevents hallucinated tool arguments, returns clean transaction list JSON. And Python directly calls save to memory, which updates the ledger and persists the new transactions. All ingestion happens without letting the LLM make multiple decisions. In the flow 2, in the phase 2 with planner workflow, what it does is it sends prompt to the planner agent. Agent calls load history method, and orchestrator runs the load tool where it gets filtered JSON, and then the feedback history is sent back to the agent along with the function called result. And then the agent generates final markdown report, which is detailed, structured, and professional. This two phases approach this two-phase approach creates a reliable multi-step functional engine, financial engine. Coming to the cell 5, which is least but not the last. Here we have the Gradio UI and the dual data execution flow. This Gradio UI is the cell which brings up everything together into a usable interface. The workflow here, how it functions is it defines what happens when the user clicks submit. If a file is uploaded, ingestion plus analysis occurs. If not, analysis only is being done using the historical memory data. While initial setup, if the memory is empty, they ingest the Kaggle dataset first. And in the Gradio layout, file uploader, we can see, and so this is the Gradio layout. So it just says that no interface is running right now. I just want to trigger this interface. And it says that file uploader and a submit button, it has a log window and a final report display. So it is all a UI visual representation of how it does. So This is all about my workflow, how my BudgetSense AI is handling the unstructured CSVs from multiple sources and how it turns out into a meaningful financial report it launches. Maybe I think I should restart my session to get this executed. Let me try until the session ends. Okay, so I just want to give the overview about how and what all we have discussed till now. So here is all the complete experience of mine working with this workflow. When user uploads a messy CSV, the ingestion agent cleans and structures the data. Python stores it permanently and Planner agent loads the last 90 days. It compares months, detects spikes, analyzes the trends of the budgets provided. AI generates a detailed markdown report and the UI using the Gradio displays it with the logs for each step. The whole workflow feels like a real financial advisor sitting behind the screen. So I also have the few further enhancements that I can work on it later on. Before we wrap up, that I would build next. So income-based personalized budgeting, visual charts and dashboards, real-time spending alerts, predictive analytic for upcoming months, saving simulations, multi-user encrypted memory, bank API integrations, exportable PDF financial reports. These are all some of the ideas in my head, not right now, but maybe in the future I'll be working on. And so the conclusion is it's the complete walkthrough of BudgetSense AI, Analyzer, and Advisor. It's a multi-agent tool-driven system that cleans messy financial data, builds long-term history, analyzes spending trends, generates actionable guidance, and majorly it is all using Gemini ADK custom tools and a clean orchestrated flow. Thank you so much for watching. I hope this walkthrough gave you a clear, full end-to-end understanding of the project and how each cell contributes to the overall structure. Thank you.